I'm Glenn Dane. I'd like to tell you about our National Science Foundation Engineering Research Center, HAMMER, which stands for Hybrid Autonomous Manufacturing, moving from evolution to revolution. HAMMER will accelerate the development and deployment of intelligent, autonomous manufacturing systems, enabling local custom production of advanced components. The center is led by my home institution, The Ohio State University, and its core partners, Case Western Reserve University, Northwestern University, North Carolina Agricultural and Technical State University, and the University of Tennessee, Knoxville. HAMMER will develop new approaches in manufacturing based on first automating agile artisan processes such as blacksmithing, welding, and inspection, and then use the tools of material science and artificial intelligence to develop self-controlled, intelligent manufacturing systems. These new autonomous systems will integrate multiple tools and enable unprecedented combinations of agility, performance, and assured quality. This will support the supply chain, medical point-of-care production, student engagement, workforce training, among many other needs. Let us show you what we mean.
Metal parts are such an important part of our modern life that they've become almost invisible to us. The production of metal and components is responsible for over 10% of our greenhouse gas emissions and play essential safety-critical roles in numerous systems. The goal of HAMMER is to deliver a superior product in less time at a lower cost and with less waste than traditional processes. To date, in the design of a metal component, we choose a process from either a textbook, a list of vendors, or experience. For example, a skeletal structure inside an airplane is usually made of wrought or forged aluminum components. The compressive deformation of forging not only gives shape to the material, but can eliminate defects, refine the structure, and impart strength and toughness. Our toughest and most trusted metal components are made this way. But it does have drawbacks. For things like airplane parts, getting access to presses large enough to forge primary aircraft components can be an issue because there are so few large presses in the world. And the design and machining of dies for any press requires significant time and money. Additive manufacturing is a partial solution. The process allows the relatively inexpensive creation of complex shapes through digital design. But without forging, it can be a struggle to obtain the best metallurgical structure. The central idea of HAMMER is to combine the operations of addition, subtraction, deformation, and transformation to allow for the design of new processes with higher quality outcomes. HAMMER will evolve and design new ways of manufacturing of metallic and other components. It's a revolution.
HAMMER will be the focal point to a new manufacturing industry based on new tools and new methods. The center will perform foundational research, educate students and technical professionals in this area, and will have a focus on bringing underrepresented groups into the field, developing an ecosystem of individuals, companies, educational institutions, and technical societies. We invite you to join us.